So I've got an idea. From what I've heard from people, that the FETs on one side are the most vulnerable. That's what gets fried. The diodes seem to almost never fry. So I'm wondering something. You know, the flow in this thing, the airflow, is pretty obstructed. You got a pretty small fan. What I've done in the past is put in a guide, and I was thinking about doing that here. This one's got the bigger cap. You can see it takes up more area and stuff, but either way, let's just go with an original one. It's almost like what everybody has. So if we put a piece of paper in, what's it going to do to the rest of the machine? You know, is this stuff going to get too hot? Well, basically it's heat sunk to the outside, which is obviously the goal here, but the fan was to, you know, some additional cooling. So I still think this could be added, so I'm going to do that right now. This is an old envelope. I went through the mail today and said, hey, you know what? I think this will work. So let's see, how are we going to do this? Going to make a little notch for the, because the whole idea is to see if we can make it run a little cooler. Since all the FETs are on this side, if we can exhaust the air past them and them only much more quickly, I think it'd be worth it. I've done this in professional circles, and you know, in the end, this gets replaced with some, you know, fire retardant material, and gets created, you know, by some vendor that's used to making stuff like that. So anyway, this I'm just trying to give you guys an example of what you could do to speed the cooling up. Okay, so it's being held up a little high, so we'll cut it a little high. Alright, so, alright. So this is our prototype. And the intention here is to shove all the air down past the FETs, since they appear to be the most vulnerable part in this. Now, I think I see right here, through right there. Let's try bending it up. And we'll see. Okay, so that almost brought it down to the circuit board. And now, see, I should have left it a little longer. Okay, so I'm going to put a crease in it there. Yeah, if I could keep it flat against this transformer, we'd be in good shape. That cap blocks an awful lot of it, but maybe not all of it. So the goal here is, how do we keep it in place? Honestly, generally, it's just usually tape. You could use hot glue, you could use you know, almost anything. The proper way to do this would be to put a thermocouple on one of these FETs, run it, see how hot it gets, and then add this and see if it makes it better or makes it worse. I've done this so much that I've never done one of these, so that's not fair. Okay, so we're going to put a crease in that. Okay, so I hope you can see the notion here is to take and force air through here instead of letting it swirl everywhere. Yeah, basically it's a closed system. It's always going to come out this vent, but velocity, the higher the velocity, I think the better off you'll be. So yeah, if we could tack that to the transformer, say, that would move an awful lot of air right past those fets and right out of here. I was thinking of taking this fan connector out and actually trying to fire it up. I guess I could put a load on it and stuff. I need to test it anyway. Let's see, is the fan hitting it? No, the fan's not hitting the paper, at least right this very second. Tell you what we'll do. One last, well. Now the other issue is this paper flammable? Is it going to cause other problems? Blah, 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 blah. So, you got to kind of pick your battles. I'm not installing this thing in a paper mill where it's going to blow up, you know, stuff. I'm just trying to... Okay, so... That's pretty good. If you could tape it down to the transformer here, it would generally guide the air through that channel much, much better. Now, okay, so what does it do to everything else? You know, I don't know. You have to just kind of play with it and decide. I crank these screws down pretty good to hold the fets, so if they're tight against the, and if they're sandwiched up against this heatsink pretty well, that'll help. But I just, you know, I'm wondering out loud here. You know, I could get shot down for it, but I've done this on, you know, home theater PCs and professionally, and I know that it has some benefits. So the other thing you have to do is instrument, you know, these diodes on this side and see if, you know, if they run that much hotter. But this would get a lot of the air from the fan and force it right past these fets and then out, and you know, that's got to help the fets. So I'm going to tweak this a little bit. It doesn't want to go down right here, so we're still... Oh, I see where it's hitting. It's hitting right on the glue. There's glue holding that down, and it's hitting right on top of it. So I'll tell you what we'll do. We're going to take these out. And see if that makes it drop all the way to the circuit board. Nope, just a bit more. Oops, I should be more careful. Okay, so here we go. So what would you make this out of? I don't know, manila folder. I'm just using an old envelope because it was laying there. It was easy, it's quick. Okay, so I didn't trim that very well around there. I could let some air leak out, but just almost touches the board. It doesn't have to be perfect. You wouldn't believe how much airflow can be diverted with just little pieces of paper. And it saves manufacturers a lot of money if this is all you have to add to bring the thermal issues into alignment, you know, like not having to add more heat sinks and, you know, things like that. So let's try this. Ooh, right down to the board. Oh, sweet. Sometimes the reason I fold that over is because it'll kind of help seal stuff off. Yeah, see, we're all the way flat to the board now. It'll leave kind of a one-way flap and it won't let the air leak as bad, so you just got to take it in stages. So, and plus it'll help fit it, you know, keep it in place. So this one's ready. I could drop this in. The fan end here is probably needs to get taped. But now I got to get the height right, which means I'm probably going to cut it off right there. Yeah, I got to get the height right. You want it to touch the lid. for it to be effective. So how do you do that? There's just barely enough height here. So how am I going to do it? This is such low airflow, it doesn't really matter. But so here's what I'm going to do. I'm going to fold its top edge. It doesn't really make any difference, so I'm going to fold it into the pressurized side. Yes, I know there's probably next to nothing here for pressure, but what happens is this folded area becomes a hinge. When you put the lid on, it'll squeeze that down and make a decent seal. You would be surprised. So let's see here. Alright, bam. Now, I gotta eyeball this across the top. Yeah, it's perfect here, but it's a little high through here, so let's try something. Let's see how this feels going on. It's dead flat, so you're not, you don't have an obstacle really. Yeah, I can see it's sitting kind of high. Alright, so this joint here needs to be snipped, and this needs to be folded down a little bit further. Doesn't have to be perfect because you want it bent upward about 45 degrees so that the lid will shove it, down, and it'll make a seal against the lid. Not perfect here. We're not talking, silicone seal or anything. We're just trying to guide a lot bigger majority of the airflow. Shoot, you know what? That's going to split right there, isn't it? Trying to keep it one piece, but that looks like it's not going to work. So let's just see how it goes here. All right. Yeah, that's good. All right, so here's what we got. You can see the airflow coming off the fan. Yes, the fan is greatly restricted, but the design, I can't help that. And it just follows the air down the side here across the FETs and directs it straight out. So is it going to overheat the rest of it? Well, I don't know. It's an experiment you have to try. A lot of you guys have a bunch of these, and maybe do this to one of them, and see which one lasts the longest. But yeah, see, now it's sitting, it's just touching the paper, just kissing it. I can feel it. So there we go. Yep. That's how you do it. Well, that's how I've done it in the past. Like I said, you're not trying to seal it perfectly. You're just trying to get the air to flow across those FETs. I don't know this circuit well enough to know where the temperature sensor is that would turn the fan on. Let's see, diodes, resistors, I see just caps. I don't see anything that resembles one. It'll look like a transistor. I know there's one over here by the voltage regulator, so maybe that's where it is. It's measuring air temperature. And it's over here. So if that's the thermal sensor clear over here, it's going to measure this area first and tend to come on first. So, I don't know, just letting you guys know what I've done in the past, and, let's see what works. All right, later.